so all that's left. Okay, so we just have a few. I have a few slides left to talk about a particular application, but just to what we were talking about before. So this Detweiler formula implies that as we go from 100,000, where we were a couple years ago, or where we currently are for several phenotypes, up to 1 million, which is where we are going to be hitting very soon for a lot of phenotypes, we're going to see an explosion of predictive power. And so this is just a really exciting time to be getting involved. You all are very lucky to be kind of getting started on this work, as a lot of this groundwork is just being finished to be laid. You get the first shot at it. So exciting times. So I just want to talk through one paper that was also on the reading list to just kind of highlight an example of how a polygenic score was used, and how we might want to think about them. This is a paper by Belsky, and this paper is really interesting. If you didn't read through it, you really should. I think it has a ton of results in it. I'm not going to be able to go through all of them here, but I think he just did this exhaustive search about how we can think about the score and all the things that it's related to. And so the main topic of this paper is we have this EA score, and what are all the things that it predicts over the course of the life cycle? He used a sample of people in New Zealand and Dunedin. He follows these people from age 3 to 38, and he has a bunch of different measures. When he and his co-authors wrote this paper, he was using the score from the first round of educational attainment, so we only had 2% predictive power in that case. And so all the results I'm going to show you today is based on even a pretty weak score. If he did it again with the current score, in fact, I think that there's efforts doing this. I saw him present once an update of these results with the more powerful score, and these results still continue to hold, but even more strongly. One of the main outcomes he looks at is what he calls an adult attainment factor. He has a ton of different measures, and so he creates this Z-score based on several of these adult measures of how what SES class you're in, things like that. And so this adult attainment factor, when you see that, just has to do with a composite measure of a bunch of measures of socioeconomic success later in life. And so in this panel here, you can think of this as a replication of the EA, the educational attainment GWAS. And so we see that what is the average polygenic score of people who have different levels of education? And so we see that people who just barely get the minimum amount, they tend to have much lower polygenic scores than those who have a university degree. So this is consistent, he replicates the results. The score actually does predict education in his sample. But then he takes it and he says, okay, well, how well does the score then predict this adult attainment factor? This measure of a bunch of levels of sort of SES success later in life. And we see that the score also tends to predict this thing. So the score is predictive even outside of just educational attainment. One kind of cute result here is that, the correlation between the score and this adult attainment factor is 0.13. But then if he does the same regression and he first regresses out his measure of educational attainment, there's still a correlation of 7%, after directly controlling for educational attainment. And so, there's lots of ways you might explain this. What I think is probably the likely explanation is that our measures of educational attainment are kind of coarse. They're not really, we maybe have just a few different categories. They're kind of noisy measures of what we might think of as like the amount of attainment that a person could optimally stop at. And so this score is a more continuous measure. And in that sense, we could even think of it as perhaps a more precise measure of the kind of thing that we're interested in when we control for educational attainment. Another implication of this result here means that as our sample sizes get larger, it may be that controlling for the education score is a better control for certain types of factors than controlling for education itself. So that's I think, a fun result out of this paper. He also shows that he can interact the score with different measures of SES. And so what we see here is, first off, in each of these categories, he's grouped a sample into low, medium, and high SES. And we see that for the low SES people, the average score tends to be something about negative. It's roughly 0 in middle SES, and it's higher in the high SES group. And so we see that the score is predicting the SES category. The slope here in these signs within each category shows that the relationship between the score and your adult attainment even holds within subgroups. In the paper, he also makes this claim that this change in the slope as you go from one panel to the next suggests there might be some kind of G by E. So the score is much more predictive of adult attainment in the low SES people, whereas it maybe is less of a factor in these high SES individuals. I don't know if this is actually statistically significant, but you could do this maybe in another sample where you just see how's the relationship between the score and whatever outcome you're interested in. How does that change in these different groups? So that's kind of one way you might measure G by E. Another thing he does is he says, what's the, is the score predictive of IQ at different ages? And so you could look at this and say, oh, well, this is increasing, which, at first glance you may think, oh, this means that the EA score is not incredibly important in terms of your IQ when you're younger, but it grows in importance later in life. So that's one interpretation. It also could be that, let's say that the IQ measured when you're very young is very noisy. So if IQ is very noisy when you're young and then you standardize it, then the relevant variation of 3-year-old IQ may not be relevant for the score. So I don't know how easy this is to interpret in this case because these phenotypes are not necessarily comparable, the units of them.
It could also be because I'm guessing all the educational attainment GWAS statistics are derived from adults.
Yeah, and so that's and I think that's kind of what they try to interpret it as. And so that's one possible explanation. But I'm just saying that I wanted to highlight that there are alternate explanations that are less social science and more statistics that could explain this relationship. So if this is just a noisy measure, then this slope is going to be a lot smaller. And so it could be that. It's not clear what the interpretation is here. So just to highlight again, you should be careful whenever you're interpreting these things that you don't take kind of whatever is the most looks most fun. You should think hard about what it is that you're measuring and if your phenotypes are comparable across groups.
So in principle, they could get some measure of the retest reliability of the IQ test at the different ages and correct for this bias, this measurement error, kind of attenuation bias you mentioned, and then see whether you still get this relationship, and then we can start looking for other explanations for it.
Mm-hmm. Yeah. If you believe that the retest at those ages is just going to be error that you could shrink and shrink and shrink by doing it over and over again. Mm-hmm. Okay, great. And then just kind of one last kind of cute thing that they do here is they wanted to look at assortative mating. And so they take people who have low polygenic scores, average polygenic scores, and high polygenic scores, and they look at the SES of their partner. And so people with a low polygenic score tend to partner with people who find themselves in the lower SES group relative to those with a high polygenic score, and they more often sort with people who are in a high SES group. And so this is some data suggestive that there might be some sort of assortative mating by polygenic score. So read this paper, it's really interesting. One last note is about, so we talked before about how the score, like if we regress the score on our outcome, the R-squared is going to be attenuated because of the error in the score. And so the problem here, sorry. Okay, so we regress the outcome on this noisy thing. And as a result, things will be attenuated. And it's because we're measuring things in the units of this noisy polygenic score, right? So it's the unit is score plus noise. And that's not a super interpretable, those units aren't very easily interpretable. What we could do, though, is we know, like as we've done with Detweiler, we know how much attenuation there is as a function of how much error there is in the polygenic score. So we could correct these estimates to be in the units of the true polygenic score to account for that noise. And so I don't want to go into this very quickly because I'm over time, but if you want to read through the slide and ask me about it later, that's probably the most efficient thing. But ultimately, the amount of inflation that you'd need to do is the ratio of the SNP heritability divided by the R-squared of the polygenic score. And that should be clear, right? Because we're saying that it's attenuated by some amount, is what we're getting in the polygenic score. And we know we should be getting this. And so we could inflate our statistics in a way that accounts for this inflation to get things in the right units. The regression, oh yeah. So if you want to inflate the regression coefficient, And in that case, the regression coefficient will be in the units of the true polygenic score in that case, although it's going to be kind of noisy. One little note too, though, is you can't just multiply that coefficient and then multiply the standard errors by that same number, because this thing is uncertain. Like, we have an estimate of this and an estimate of that. And so if you just multiply the slope by that thing, you're adding a little bit of sampling variance. And so, in principle, you would need to make some sort of correction to your standard error to account for that uncertainty. This is stuff that's not been worked out super carefully yet, but it's kind of an active area of research. Mm-hmm.
So that's just essentially using like the observed PGS as like an instrument for this like overall SNP variability, or is it?
Yeah, it's not quite the same as an instrument because we're just multiplying by a number.
So you mean like walled estimates, or like where you just kind of scale it up? Yeah.
Your fellow student Casper has a paper that does what you proposed.
Yeah. So wherever Casper went, oh, there he is. Yeah. So Casper has another approach that maybe would write your polygenic score in the units of the polygenic score too. That involves actually having one score that you're using as an instrument for another one if they're estimated independent samples. So that's an alternative approach. So again, this is stuff that people are thinking about working on. How can we write these scores in terms of the units that we're interested in? Okay, that's great.
I don't know if IC will talk about this, but I think so far in the talk we have, we are estimating, we're using polygenic score from one trait to sort of see how much of the variance it predicts in other trait. Now I think that's perfectly fine if the two traits are exactly the same, but if you're doing cross-trait polygenic scores, I haven't yet come across papers that sort of uses polygenic scores from multiple different traits, which are all sort of related to the main trait. Is there sort of any method out there? Is there are people thinking about things like this?
So, Jonathan he's going to talk about a paper related to this as well, where he's going to use scores for different traits and use it to predict fertility, and then you could interpret. So what that would mean, the coefficient on that is going to be like, how does variation in this predictor for one trait affect the variation in whatever it is that you're interested in? And so there's, I think, a number of research questions that, or something like that would be the appropriate thing to do. So there are such papers, and I think that papers like that are things that you guys could be thinking about in terms of applying polygenic scores to the questions that you have.
In the case of the Belsky et al. Paper, the motivation was to try to
yeah.
understand the mechanisms through which the score is ending up mattering for education by seeing what does it do to early life educational experiences, or things like with the age at which you start talking. So that's another reason.
Yeah. In general, I think sort of follow-up work on PGSs and longitudinal data sets have much richer data than what we can use in GWAS. Is a pretty good, pretty interesting thing to work on.
Yeah.
Lots of opportunities there.
Yeah.
Going to grow.
Yeah, so as David's saying is that if like one of the really interesting things that you could do going forward is if you can apply polygenic scores to longitudinal data, there's probably a lot of really interesting questions that you can ask in a setting like that.
That's another question, either Patrick or Dan or whoever else. Have people looked at, what is this effect, this polygenic effect of education going through? Is it IQ? Have people tried to control for the IQ PGS? I have trouble saying PGS because I always call it PRS. But anyway, the IQ PGS and the education PGS, and is there anything left over for the education PGS?
So probably Jonathan's the best person to talk about the mediating.
Is it going to be something you're going to cover later?
For you mean,
For this particular question?
yeah.
No?
Well, I'll talk a bit about it tomorrow in the case of fertility.
Okay.
Do you want to
The
give a quick
mediation
answer about the
analysis you need
EA polygenic score, Jonathan?
Yeah. So I mean, I actually don't really know what's the main mediator for.
But we've looked at a couple of potential mediators, right? We looked at the effect of we looked at the extent to which a measure of IQ and some measures of personality traits.
Oh, for risk, we did that.
No, well, I'm talking about I think the question was about the educational attainment polygenic
Yeah.
score. So we looked at openness to experience and conscientiousness.
I mean, presumably the
I was
SNPs
thinking
aren't
completely
actually.
aside the point. I was completely
You
outside
had those
the point.
analyses. So,
Yes.
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 Yeah.
Okay. No. So what we saw is that yes, indeed, we did see that IQ is mediating this, as well as some of the big fives.
Mhm.
I think there was openness to experience. I forget the other ones.
But
60% of the effect was
yeah, but it was there was a something like that. A substantial share of the effect was mediated, but not 100%.
I mean, these are
the
lower.
numbers we were getting, and they were noisy estimates. I think the numbers we were getting were like 40% for IQ and like 25% for openness to experience.
What, 40% of the effect was mediated by
It's not
IQ?
coefficient 4 by
Yeah,
40%.
okay.
But some of that's going to be, like you can't perfectly control for it because we don't have the true polygenic score for some of these things.
Mhm.
So, I mean, the estimates that we're getting there should be thought of as lower bounds of how much is being mediated, right? Or did we do some sort of correction for the noisiness of the measure?
We didn't do
Oh, we actually mediated with the, oh, okay, yeah. So I was thinking it's kind of like this thing here, where we say what's the predictive power of the score controlling, I guess it's not controlling for an other thing, so that's a slightly different
So you
question.
control for IQ and control for
Yes.
personality.
Yes.
But
Yeah.
aren't IQ and openness to experience also correlated with each other?
Yeah. So Jonathan did a multivariate mediation analysis.
Yeah.
And I guess he needs to remind himself what he did.
That's not what I did.
Remind you. He'll
Yeah.
update. How about he'll update us in a couple minutes after he's.
I have to remember what the effects were.
Mhm.
It's around 50%, but I want to give a more precise number.
Yeah, so that's true. And that's going to go back again to trying to understand what these scores are. I think that's interesting work that can be done.